So these are the solutions to the 2021 Year 7 fractions test. So question 1 started with the requirement to reduce the following fractions to their simplest forms. So what we do, remember, is we look for a common factor of the numerator and the denominator. Ideally it's the highest common factor, but you can just use a common factor. So I know that 3 goes into 3 and 12, so our common factor, in this case the highest common factor, is 3. So that's going to be 1/4. Now 16 over 40 you could divide through by 2, okay, and we're going to divide through by a common factor here. That gives us with 8 on 20. Now you just got to be good enough to recognise that that wasn't the highest common factor, because 8 and 20 are both still divisible by 2, and in fact they're both divisible by 4 as well. So let's divide that by 4 and divide that by 4, and we get 2 on 5, 2/5. 12 on 3 is the same as 3 on 12, except this time what we're going to do is divide by 3 and divide by 3, and our answer is 4 on 1, probably better known as 4. Okay, question 2 required us to complete equivalent fractions for the following. So what do I do to 5 to get it to look like 50? By using equivalent fractions. Times it by 10, times it by 10. That's 20 on 50. This one was a little bit harder because a lot of you would have thought, how do I get 24 into a 2? But actually what I did with this one, or what I would do with this one, is look at 180 and 60 and look at the link between these two. And if I divide this by 6, what I get is 30. So 180 divided by 6 is 30. So if I divide this by 6, what I'm going to get is 4. Alright, and once I do that and get 30 on 4, I can see that 4 divided by 2 is equal to 2. So 30 divided by 2 is 15. So that number is 15. That number there is 4. Convert the following mixed number to an improper fraction. So remember the technique was we multiply them and add that to the result, and the original denominator is still our denominator. So this is the same as 3 times 5, which is 15, plus 2 is 17, over the original denominator, 5. This one here is the reverse, so 45 on 6 means how many times does 6 go into 45? So 6 sevens are 42. From 42 to 45 there's 3 more, and our denominator, or the number of parts in the fraction, is still 6 parts. Now 7 and 3/6 is the same as 7 and a half if I divide through by the highest common factor of 3 and 6, which is 3. Okay, circle the fractions which are less than a half. Okay, so 5 over 10 is a half, so it's not less than a half. What about 7 over 16? Well, 7 doubled is 14, so 7 on 14 would be exactly a half. Because we've got 16 parts, or 2 more parts to this, that means 7 must be less than, or 7 on 16 must be less than a half. Now, let's have a look at this one. Now, 9 on 18 is a half, so 9 on 19 is going to be less than a half. 11 on 20, well, 10 on 20 is a half. 11 on 20 means we've got more than a half, so that one should not be circled. That should be crossed out. Well, it doesn't have to be crossed out, just not circled. Now 5 on 12, well, what would be 5 on 10 would be a half. So that is less than a half, that one. Okay, for each of the following, insert an equals, less than, or greater than. So 2 parts out of 7 is less than 6 parts out of 7. This one here, to compare these fractions appropriately, what I can do is times that by 3, times that by 3, times that by 5, times that by 5. So just make fractions of equal parts. That's 5 on 15, and we're comparing it to 3 on 15. And what is evident is 5 on 15 is more than 3 on 15, so 1/3 is greater than 1/5. Now this one here, do you need to actually find fractions of equal parts? That's my question here. So many of you tried to on this one here, but if I look at this, 30 parts out of 80 and 12 parts out of 16, this is much closer to 6 parts out of 16 or 1 than this is. This is less than a half, this is more than a half. So that one automatically is less than 12 on 16. Okay, evaluate the following, giving your answer in simplest form. So this one here, 7 parts out of 8, remove 5 parts out of 8 is 2 parts out of 8, which is 1 part out of 4, or a quarter. This one here is going to be times by 5, times by 3, times by 3, times by 5 to make fractions of equal parts. So that's going to be 5 on 15 plus 9 on 15, which is 14 on 15. So again, what the target will be with that one is to make them fractions of equal parts. Alright, now this problem here, you could convert these both to improper fractions, but should we do that? Yeah, half and a quarter. Yeah, I am going to do that. So 4 fours are 16, 19 on 4, plus 5 twos are 10, 11 on 2. Times by 2 and times by 2, we've got 19 on 4, plus 22 on 4, which is equal to 32, 41 on 4. Could be left as that, or you could convert that to a mixed fraction, which is 10 and a quarter. Okay, this one here. Now, because 2/3 is more than 3/8, I'm going to subtract without converting to an improper fraction because it's just easy enough. So what I'm going to do is make fractions of equal parts. So that's 5 and now the lowest common denominator will be 24. So I've got 5 and 16 over 24. Take away 2 and 9 over 24, which is equal to, so 2 from 5 is 3, 9 from 16 is 7 over 24. Now you could very well have converted that to impropers, which is 15, 17 on 3, take away 2, 8 is 16, 19 on 8. Now the only problem is times 3 times 8 times 8 times 3 is the numbers are just getting rather unruly. So this one here is better if you leave this one as a mixed fraction. The only time I do this conversion to an improper is usually when I know that this fraction here is more than this fraction here. Okay, evaluate the following, giving your answers in fully simplified form. So this one here, what we do is we check if we can cancel any of these. So if we can simplify that, or we can find a number that goes in a 5 that also goes in a 4, and a number that goes in a 1 that also goes to 6. Now the only thing I can find there is 1 for both of those, so it means it can't be simplified. So we go ahead and multiply the numerators and multiply the denominators, 5 over 24. This one here, we'll write that as 4 over 1, and note that 4 goes into itself once and goes into 8 2 times. 1 times 3 is 3, 1 times 2 is 2. Many students converted that, that's fine. Okay, this one here, now when we divide by a fraction, it's the same as the original fraction multiplied by what's called the reciprocal, or that fraction flipped. So what we do here is we look for anything that we can cancel down. So I can definitely fit 4 into 12 as well as 16, goes 4 times and goes 3 times. I can get 5 into 15 3 times and into 35 7 times. 3 times 3 is 9, 7 times 4 is 28. Now this one here, you've really got to do this one via improper fractions. Now if you want to use the mixed numbers, suggest drawing up an array with 3 and 3/8, 1 and 2/3, then multiplying through to work out each of these and then adding the results together. But much easier if you do the conversion. So 3/8 are 24, 27 on 8 times 5 on 3. Let's look to see if we can cancel, and we can. So we've got 9 times 5, which is 45 on 8, and there's no reason why you should convert that to a mixed fraction. We're not told to, so it doesn't matter. Now this one just requires you to understand that the division has to be done before the subtraction. And when we divide fractions, what we do is it's the same as multiplying by the reciprocal. This one cancels down a bit. So we're going to get 3 2/3 take away 4 times 1 is 4 and 3 times 1 is 3. Now this is 3 2/3 take away 4/3. Might be easy to see this via impropers. 3 3s are 9, 9 and 2 is 11 on 3. Take away 4 on 3. Answer is 7 on 3. Okay, multiple choice. Now you're allowed to use your calculator for this one here. This is not the same calculator you guys have got, but it's similar. So let's just flick it on. And you could use the, I forget what the name of the fraction, n on d, I think it is on your calculator. 1 on 2, 4. So when we type that in, remember that the calc automatically simplifies for us. So yeah, quarter. Okay, there are 36 Smarties in a packet. Zach ate 2/9 of the packet. So this would be 2/9 of 36, or 2/9 multiplied by 36 over 1. That goes into itself once, and into 36. 9 4s are 36, yeah. 1, 2 4s are 8. 8 Smarties. Could also do that on the calculator. 2 over 9 multiplied by 36. Ooh, whoops. Two over 9. Where's the times button? Eight. Okay, 8 people ate 3/4 of a pizza each. How many pizzas would be eaten? That's 8 over 1 times 3 over 4. So that's 8 lots of 3/4. That's once, twice, 6. 6 pizzas. Okay, from a 2 kilo packet of flour, what's the total number of 1/8 kilogram portions of flour that can be taken out? So we're looking at 2 divided by 1/8. So how many times does 1/8 go into 2? Well, that's the same as 2 times 8 over 1. So dividing by a fraction is the same as multiplying by its reciprocal, which is equal to 16. So we can do 16 of them. A dog eats 5 4/9 of dog food in 7 days. How much food does the dog eat in 1 day? So just say I said the dog eats 14 kilograms in 7. How many in 1? All you would do is 14 divided by 7. So this is the same, except we're going to do 5 4/9 divided by 7. It's just a fraction this time. So 5 times 9 is 45. 49 on 9 divided by 7, which is the same as 49 over 9 times 1 on 7. So that's going to be 7 on 9, D. Okay, a survey was taken of 120 people as they left the local sandwich bar. Give all your answers in simplest form. If 80 were male, what fraction was male? That's 80 out of 120. Divide by 10 and divide by 10, and divide by 4, divide by 4. That is 2/3. What fraction was female? Now, if 2/3 are male, then 1/3 will be female, not male. If 45 were under the age of 21, what fraction was under 21? So 45 out of 120. Get your calculator to help you out with this one if you wanted. 45 over 120 equals 3/8. What fraction was 21 or older? That is not under 21. That's going to be whatever's left over, 5/8. If 3/4 of all customers bought a drink, how many had bought a drink? So that's 3/4 times 120 over 1, divide by 4, divide by 4. That's once, and 4 goes into 120 30 times. 3 times 30 is 90. Now also, again, you can use your calculator. 3 over 4 times 3 over 4, let's try that again, times, what was it, 120 equals 90. If 3/4 of all customers bought a salad roll, how many had not bought a salad roll? So that's going to be 7 out of 10 didn't buy a salad roll. Of the 120 people, 7 times 12 is 84. Teresa, Isabel and Bryce worked on a mathematical problem, came up with the answers of that. So Teresa is 8.5. Isabel is 8 2/3, and Bryce is 8 3/5, and correct was 8 7/12. So essentially what we want to do is find a common denominator and get all the fractions of equal parts. Now we're only really interested in this part here, the fractional part, because all of them have got 8 wholes. So it's just going to be who's closest to 7/12. Is it going to be Teresa, Isabel, or Bryce? All right, let's find out. So let's convert them all. So I think all of these numbers go into 60. Yes, 60. So times by 5 times by 5 is 8 35 over 60. This is going to be times 12 times 12. This is going to be 8 36 over 60. So Bryce seems pretty close straight away. This is going to be times 20 and times 20, 8 40 over 60. And this one here times by, what is it, 30? 30, 8 30 over 60. What's abundantly clear is that Bryce is the closest. Okay, he's out by 1/60. Pretty close. Okay, this last problem was pretty tough. It says here if 4 on 3 times 5 on 4 times 6 on 5 times a following sequence of number equals 4, what's the value? So this ... implies that the sequence continues. I think the first thing we should do is work out what 4 on 3 times 5 on 4 times 6 on 5 actually is. Let's work out the answer to that. So to do that, we'll go 4 on 3 times 5 on 4 times 6 on 5. So that equals 2. Now let's do 4 on 3 times 5 on 4 times 6 on 5 times, let's do the next number in the sequence, which is 7 on 6. Now we already know that this part here is equal to 2. So in the next line, all I'll do is 2 multiplied by 7 on 6. And that is 7 on 3, or 2 1/3. Now I wonder what would happen is if we did 4 on 3 times 5 on 4 times 6 on 5 times 7 on 6 times 8 on 7. So that's going to be the same as, this is 2 1/3 times 8 on 7. Okay, so 2 1/3 is 7 on 3, so we'll go 7 on 3. Try that again. 7 on 3 times 8 on 7. That's 8 on 3. Okay, and 8 on 3 is 2 2/3. So what seems to be happening here is the pattern is for every term that's added, it increases the total by a factor of 1/3. Not a factor, by an additional 1/3. So 8 on 7 gets it up to 2 2/3. So 9 multiplying by 9 on 8 will get us up to 3. 10 on 9, 3 and a third. 11 on 10, 3 and 2/3. And our winner will be 12 on 11, which will get us to 4. Therefore, A is equal to 12 and B is equal to 11, or it is 12 on 11 equals A on B.